The island of Madagascar and the continent of Africa have been separate for more than 100 million years. But ancestors of Madagascar's unique collection of lemurs and other mammals only arrived 60 million to 20 million years ago. With no land connection, how did they migrate over 300 miles of ocean to the island? On natural rafts, according to research from Purdue and Hong Kong universities. Computer simulations of ancient ocean currents show the flow at that time could have delivered the animals on logs or vegetation mats blown to sea by powerful tropical storms. The current flows south and west today, but at the time animals arrived on Madagascar, the current moved quickly eastward toward the island.
Africa and Madagascar were basically the same distance away from each other as they are today, but they are all displaced about 15 degrees further south. And because they were displaced further south, they were in a different ocean current system. If you move the whole thing south, all of a sudden there's an ocean gyre that goes like this and transports rafts from Africa to Madagascar.
Huber and colleague Jason Ali in Hong Kong say conditions ripe for transporting animals to the island by sea were probably rare, perhaps once a century, but that is sufficient through the vast depths of geologic time to see the evolutionary process leading to the island's current animal population, one found nowhere else on the planet. Fossil and genetic records also indicate that the animals of Madagascar arrived in sporadic, widely spaced events by single species, which backs the rafting hypothesis.
That wouldn't be something that happens with a land bridge, and it wouldn't be something that happens through most of the other mechanisms that could possibly explain how mammals got to Madagascar. The only thing that really explains that kind of pattern is something that's unlikely, but possible on geological timescales. And the rafting hypothesis is a really good example of that. What we've shown with this study is that it's physically possible for this to have happened.
The agreement of the results with fossil and genetic indicators also helps confirm the accuracy of Huber's climate simulations. On supercomputers operated by ITAP, Purdue's Central Information Technology Organization, he simulates the ancient climate during periods when the Earth was much warmer than today. The computer modeling is one way of better understanding the potential impacts of global warming in the future. The Madagascar study may not be Huber's last look at animal migrations. How primates, monkeys, first appeared in South America is another scientific mystery, for example.
It's actually a big question. Where do these New World monkeys come from? How did they make it there? And one of the main hypotheses is that they also rafted from Africa. Now that distance is a lot longer. If you think that the distance from Africa to Madagascar is long, well, the distance from Africa to South America at the end of the Eocene, when we think they made it about 35 million years ago, was about 1,500 kilometers. So that's one of the things that we're going to study next is, can you explain that by having really fast ocean currents and rafting?